discussing the fundamental theorem of calculus. So let's discuss a few basic rules for this theorem. So I'm going to be given y is equals to the integration from x to a constant, and then I have something here. It's gonna be it's gonna have a variable that's not x. Let's say t, for example, dt, and I need to find the derivative. That's my job. Now the first condition is that my x or variable should be in the upper limit always. Now, if I have y is equals to here a and then x, let's say, and then I have my function. What do I do here? I need to fix this problem. I'm going to switch them, so it's going to become y is equals to x with a, but with a negative sign, because I switched both of them. Now after I do that, I'm going to get the x and substitute it into the t that's given. Now I know now that I'm talking like this, it's probably going to sound confusing, but now when we start solving the examples, it's going to make more sense. Okay, so I'm going to put the variable here into t, which is the variable that they gave me, and then I'm going to multiply by the derivative of the upper limit. Now let's get the question and solve it so that it can make more sense. Now, I'm given my first question. I have the integral from x to a of t cubed plus 1 dt, and I need to find, this is y is equals to, I need to find dy by dx. Now, I don't know why, but the first thing we have to do is, and remember this as a step, we're gonna do d by dx multiplied by y is equals to d by dx integration x a of t cubed plus 1 dt. Now, why do we do this? We do this to show that the d by dx is going to cancel the integral. So my answer is going to be without any d by dx or an integral. So and now I'm just going to solve normally. I just do this so I show both of them cancel, so I can just do this d by dx and just cross both of them. This is enough for them. Now I have that my x is up, like my variable is in the upper limit, so I can continue solving normally. So what am I going to do? We said I'm going to get the upper limit and put it instead of the t here. So it's going to be x cubed plus 1 multiplied by the derivative of the upper limit, which is just 1. So multiplied by 1, so this is just going to be x cubed plus 1. And that's it. Now this might seem a bit confusing, but as we solve more questions, it's gonna make more sense. Okay, so this is my new example. The first thing I'm going to check is my limits. I have a constant up and a variable down. We cannot solve it if it's like this, so we are going to flip them. We are going to put a negative sign since we flipped the limits. x5 of 3t sine t dt. Now, like we said before, we're just going to put d by dx on both sides and just cross the d by dx with the integral. Now, keep in mind the negative sign does not go anywhere. So my answer is going to be what? I'm going to write the negative here, and then I'm going to get the x, and I'm going to put it instead of my t's. So negative 3x sine x. Then, what is the derivative of x? The upper limit, it's 1, so times 1. So my final answer is going to be negative 3x sine x. Now, and for me, if I solve it, I just literally directly do 3x sine x times the derivative. I just put x instead of the t. But yani this thing d by dx, we just have to do it so we show why it cancelled. But other than that, we're literally just putting the upper limit instead of the t and multiplying by the derivative of the upper limit. Okay, now we have this question. Now here they ask me dy by dx, so obviously the answer has to be in terms of x. That's why I think we do the d by dx thing. Now let's say I don't have to show my work. I would literally like instantly solve it like this. Cosine x squared times 2x, which is my final answer. I just put the x squared here and I multiplied by the derivative of x squared. That's literally it. And just literally put d by dx and just cross both of them. So I just put the upper limit, which is my x squared, into t. So cosine x squared multiplied by the derivative of the upper limit, which is 2x. That's it. But you just do the d by dx to show that the integration cancels. So just write d by dx at the end, or just cross it out with the integral, and that's it. Okay, so here I have the integration, and I have 4 and 1 plus 3x squared as my limits. I have a constant in my upper limit. We do not want that, so I'm going to rewrite it. Y is equals to, since I'm going to switch the limits, I'm going to put a negative, and then I'm going to put 1 plus 3x squared up, 4 down, 1 plus 2 plus t, 1 over 2 plus t dt. Now, like I said, if let's say I don't have to show my work or anything, I'm literally just gonna do 1 over 2 plus 1 plus 3x squared. I just put the upper limit instead of t, multiplied by the derivative of 1 plus 3x squared, which is 6x with a negative sign. That's literally how I do it. And then negative 6x over 3 plus 3x squared. If you want, just do it like this, and then at the end just write d by dx here and show that it cancels with the integral. So this is my final answer. Okay, this is my next question. Let me check my upper limit. Yes, it is a variable, and I have my constant in the lower limit, so I don't have to change anything. Now I'm just going to directly solve it, put the radical instead of the t, so cosine radical x multiplied by the derivative of the upper limit. The derivative of radical x is 1 over 2 radical x. We did the radicals in, we did the derivatives in the previous exam. Also, if anything, just memorize that radical x, the derivative of it is 1 over 2 radical x. Also, anyway, this is something I just memorized, so just keep it in mind. So my final answer is going to be 1 over 2 radical x cosine radical x. Now, because they need you to show your work, just put d by dx here, cross it and cross the integral to show that they cancel, and this is going to be my final answer. Okay, now here, what's the difference between this and the previous questions? They already put for me the d by d theta here, so I can just show that these two cancel, and I'm just going to solve normally by getting the tan theta into the y, so secant squared tan theta multiplied by, what's the derivative of tan? It is secant squared theta, and that's my final answer. So if we want to revise, the first step I'm gonna do is check my limits. Check the limits. Check the limits. The upper limit, the one up, which is this one, should always have a variable, let's say x. And this one should always be a constant. Now, if that's the case, I can directly solve. If not, I'm going to flip them and put a negative outside. The next step is I'm going to put the upper limit or substitute it instead of the t. In our case, most of them were t or the variable given in the equation. And then step 3 is just multiply by the derivative of the upper limit. And these are my 3 steps. That's it.